Hello and welcome to Controllers Tech. Today we will see how to interface the 7-segment display with STM32 microcontroller. These displays come in different varieties, some need to be connected directly with the MCU, while others have some special LED drive control chip soldered into the board. The segment display I am going to cover has the TM1637 chip connected to the LED. TM1637 is a kind of LED drive control special circuit, with a keyboard scan interface. Since we don't have a keypad, we will just focus on the LED drive part of this IC. The display has 4 different digits, and each digit has 7 segments. A segment basically means the LED, and there are 7 LEDs assigned to each digit. Other than that, it also has the colon in the middle, which can be used during the clock display. Each digit has a different address mentioned on the top, but we will talk about it later in the video. I am going to control this display using the STM32F103 controller, and here you can see the connection I made. The blue wire is the clock pin, and yellow is the I/O pin. We only need these 2 pins to control this display, clock and data. I have connected the clock pin to PB10 of the MCU, and the I/O pin to PB11 of the MCU. Other than these, the VCC pin is connected to the 3.3 volts, and ground is connected to the ground. This is the data of the TM1637. We will only see the important points in this datasheet. By the way, this display is also available on Controllers Tech Store, so the Indian users can purchase it from there. You can also download the schematic and datasheet from the product page itself. I will leave the link in the description. Let's start the Cube IDE, and create a new project. I am using STM32F103C8T6. Give some name to the project and click Finish. Let's start with the clock setup first. I am selecting an external crystal to provide the clock. The board has 8 MHz crystal on it, and let's run the system at maximum 72 MHz. Go to Sys Debug, and enable Serial Wire Debug. Let's set the pins now. I have connected the clock pin to PB10, and I/O pin to PB11. So set these pins as output, and name them accordingly. Now go to GPIO setting, select both the pins and set the maximum output speed to high. That is all we need to set up. Click Save to generate the project. We will create a separate library file for this display, so create a new source file in the source directory, and a new header file in the include directory. Let's take a look at the datasheet now. This datasheet mainly covers the keypad interface, but we will just focus on a few things needed to interface the display. Here you can see the address for the individual grid. A grid actually represents a digit, and this driver is capable of interfacing 6 digits together. We have only 4 digits on the display, so the grid address will vary from C0 hex to C3 hex. This is what I have mentioned in the first image we saw. The colon in the middle of the display comes under the address C1 hex. It is controlled by the bit B7 of the segment, but we will talk about it later. The rest of the digits have their individual addresses. As mentioned here, in order to send a start condition, the clock should be at high level and the data pin should change from high to low level. You can see the same in this timing diagram. The clock is at high level, and when the data changes from high to low, this is considered a start condition. Similarly, to send a stop condition, the clock should be at high level, and the data pin should change from low to high. You can see the stop condition in the timing diagram. The data transfer is always answered with the acknowledgement signal. Here the device pulls the data pin low at the falling edge of the 8th clock cycle, and then releases the line at the end of the 9th clock cycle. There are different modes available in the TM1637. The first one is command data transfer, which is used for reading the key data, the keypad. We will skip this one, as we are using it to interface the display. The second one is used when you want the address to auto-increment, and the third one is used for the fixed address mode. I will use this auto-increment mode, as this is more useful right now. Here we send the command 1 first, which should be the set data command. Then send the command 2, the set address command. Then send the data bytes. Since we have only 4 digits, we can send a maximum of 4 data bytes at once. Finally send the command 3, which is the control display command. We will see these commands in detail when we write the code. I have another datasheet of the same device, but this one contains the sample code in C format. This code is actually written for the AVR MCU, but we will use it as the reference for our STM32. Alright, let's open the TM1637 source file. Include the main header file along with the TM1637 header file. Let's write a function to send the start condition to the device. We will modify this start function as per our MCU. Let me first define the functions to set and reset the clock and data pin. It will be easier for us to call these functions directly later in the code. Alright, here the clock is set to 1, so call the function clock high. Then the data pin is set to 1, so call data high. Then there is 2 microseconds delay, and later the data is set to 0, so call data low. Now let's write the function for the delay. The delay does not necessarily need to be in the microseconds. The device does not have any such requirements as per the datasheet, so we will just write a simple function to provide a very small delay. My system clock is at 72 MHz, so I am setting the maximum value for the variable j as 7. If you are running the system at 50 MHz, set it to 5, or for 100 MHz set it to 10. The start function is as per the information in the datasheet. First the clock and data should be high. Then while the clock is still high, the data should transit to low. This generates a start condition for the device. Let's write the function for the stop condition. We will modify the code for the stop condition provided in the datasheet. Reset the clock, then reset the data, then set the clock, and in the end set the data. This is again as per the instructions provided here. First both clock and data are low. Then the clock transits to high while the data is still low. And finally the data transits to high while the clock is high. We have both start and stop functions. Now we will write the function to read the acknowledgement from the device. First reset the clock pin, and then wait for some time. Here the function checks for the state of the data pin, and it waits for the data pin to go low. But we have set the data pin as output, so we can't perform this check, so we will skip this step. If the device is responding, the data pin will anyway be low. Here you can see the acknowledgement on the timing diagram. First the clock is pulled low, and then there is a considerably larger delay. At this point the data pin should be low. Then the clock is set to high, and after a small delay it is reset back to low. Next we will write the function to write a single byte to the display. This byte can be a command, or data. Let's modify this code according to our functions. Here we extract a single bit from the byte data. If the bit is a 1, we set the data pin, and if the bit is a 0, we reset the data pin. Note that the data is transmitted while the clock is low. This is as per the instructions in the datasheet. After transmitting one bit, the byte is shifted to the right by one place, and the same operation is performed again. Now we will write another function to send the actual data to the device. The parameter of this function will be the digit address where the data needs to be displayed, and the pointer to the data. We have the code for it in the datasheet, but instead we will write it by understanding the sequence. As you can see here, to write the data to the display, we need to send the setData command, followed by the setAddress command, followed by the data, and at last the display control command. Here is the table describing the setData command. It is basically used to configure between writing data to the register, or reading the key scan data, along with the address mode you want to use. We want to write the data to the display, along with the automatic address mode. So our command will contain a 1 only at the B6 position. To write the command 1, we will first send the start condition, followed by the command 40 hex. Then wait for the acknowledgement, and send the stop condition. Next we need to send the setAddress command, followed by the data bytes. Note that there is no stop condition between the address command and the data, they should be sent continuously. Once all the data bytes have been transferred, we can issue the stop condition. The address is already defined in the parameter of this function, so we will pass the same address. Let's define one more parameter here, size of the data. Now first send the start condition. Then send the command to the address, and wait for the acknowledgement. Now send the data bytes, and wait for acknowledgement after sending each data byte. Once all the data has been transferred, send the stop condition. Finally we need to send the command 3, the control display command. This command controls the display brightness, along with the backlight control. We definitely want to turn the display on, so the bits B7 and B3 must be 1. Bits B0 to B2 controls the brightness of the display. The more the pulse width, the brighter the LEDs are. I will set it to a random value, let's say to 1/4 of the full brightness. So the command 3 value I have now is 8 hex. Let's send the command 3 in the same pattern. Send the start condition, followed by the command 3 byte. Then wait for the acknowledgement, and finally send the stop condition. Let's define this function in the header file, so that we can call it from the main file. We will write the main file now. Include the TM1637 header file. Let's give some delay before we can proceed with the function. This delay is not necessary, I am just adding it. Now call the function TM1637 write data. The address will be the address for the first digit, C0 hex. The data is basically decided based on which segments of the digit you want to turn on. Here you can see each digit has 7 segments, from A to G. Here each segment represents 1 bit. Now let's say I want to display the letter A. To do this, I need to turn on the segments A, B, C, E, F, and G. Similarly, if I want to display the number 2, I need to turn on the segments A, B, G, E, and D. Here you can see the binary data respective to each digit, or letter. I want to display the letter C, so let's copy this data from here. Now let's define a variable data, and assign the binary data to this variable. Since the function takes the pointer to the data, we will pass the address of the variable here. The size is 1 byte. Alright, let's build and flash the project to the board. You can see the letter C being displayed on the first digit. Now I am changing the address to C1 hex, and flashing the code again. We now have the letter C on the second digit also. The data is being retained in the first digit. As I mentioned earlier, this colon is also part of the address C1. To turn on this colon, We need to write a 1 to the most significant bit of the data. So let's set this bit to 1, and flash the code again. The colon is also turned on now. Let's keep going, and now I am setting the address for the third digit. The letter C is now being displayed on the third digit too. And finally, we will display this letter to the fourth digit also. So we can control the data on the individual digits by setting the respective address. Now we will see how we can send the data for all the digits at once. Here I am defining an array of 4 bytes. I want to display the number 1, 2, 3, 4 on the display, so let's copy the binary data for these numbers. Now send the 4 bytes array to the display, starting from the address C0 hex. You can see the number 1, 2, 3, 4 on the display. So we successfully interfaced the 7-segment display based on the TM1637 driver IC. In the next video we will write functions to print the numbers directly on the display. We will also program to use this display as the clock. This is it for today. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.